And these are the 6.2 practice answers. Okay. So the first one here, the manager of a grocery store records the total amount spent in dollars for each customer who makes a purchase at a store during a week. The values in the table summarize the distribution. So there were 749 customers, spent a mean of almost $30, spread of this, minimum, quartile 1, median, quartile 3, and the maximum. Okay? So is the median unbiased? Okay, so we're trying to, this is the true median. If it's unbiased, okay, here's our sample. They did a size 10, a sample of 10 customers. We took a sample of 10 customers, found that mean. Found a sample of 10 customers, found that median, because we're talking about median here, right? The 10 customers, sample of 10 customers, found the medians. 10 customers, found the median. 10 customers, found the median. They did this 1,000 times, and this is what all those thousands are. Okay? Does it appear to be biased or unbiased? Okay, so the middle of this data here appears to be about 22. Okay, about 22. And our median up here is just almost a little over 22, right? So that's pretty close. So as long as the mean of the sampling distribution, so here's our sampling distribution, as long as the mean of the sampling distribution equals the parameter, the true parameter, which they're pretty close, right? One's 20, right around 22, and there's around over 22. They're very close. We're going to say it's an unbiased estimator. Okay? Whereas number 2 then says, what if we increase the sample size instead of 10? Let's say we increased it to a sample size of 50. What would happen to this distribution here? Okay? If we have more people in our sample, it's going to be centered more here. So we're not going to have this out here. We're going to be all in here. So it's going to be less spread out. Okay? It's going to look more like this instead. Less spread out. So the sampling distribution would be less spread out. It'd be more centralized around the true median. The estimate, which means the estimate would be more accurate. Okay, it would be more accurate. Okay, let's look at another example. Number 2, the minimum. Okay, the true minimum was 20 cents. Somebody came in and spent 20 cents at the grocery store. Okay, now, if I take 10 people out of the 749 people, right, and found their minimum, some of them had a minimum, okay, so these are all the different minimums of 1,000 different people. So this is our sampling distribution right here. Okay, the minimum here, the average, right, the average minimum was about 550. Okay, is that anywhere close to our true minimum? Okay, the average of our samples, is the average of our samples equal to our true average that true minimum we're trying to find here? No. Okay, so the sampling distribution of minimums was 5.5. Our true minimum was 0.2, not equal to each other, not close to each other. Therefore, it's a biased estimator. It does not give a good representation. The middle of these numbers is not a good representation of what we're trying to find. Okay, now, what would happen to this distribution if I increased to 50 people instead of 10 people? Once again, instead of being here, it's going to be like this, right? It's going to be less spread out. But does that change whether it's a biased or unbiased? No. Our center is still going to be here, which makes it biased. Okay? So the sampling distribution would still be biased, but it would be less spread out. Okay? The distribution is less variable, but it's still biased, giving us an inaccurate answer. Okay? Next one. In a residential neighborhood, the median value of a house is $200,000. So we know that's true. The median of the population is 200,000. For which of the following sample size, a smaller or a larger sample size, would we get sample medians that are greater than 250,000? Okay, so let's think about this. If this is my population, right, I know the median is right here around 200,000. What would the two sampling distributions look like? Okay. Now, median's going to be unbiased, so both of them are going to be centered right here around 200,000. Okay. Okay, but 10 versus 100, what's the difference between those two? Well, we can see. sorry, the population here is around 200,000. And we have size of 10 and size of 100. Both are going to be centered at 200,000. But what's the difference between the two? We know that the more in our sample, the more close together it's going to be. Whereas the less in our sample, the more spread out it's going to be. Okay? So let's say that right here is 200. Right there is 250,000. Okay, so this one would have that percentage of them that would be greater than 250,000. This one would be of this percentage. Okay, so n equals 10 is much more likely to have samples greater than 250,000 because it is more spread out. Okay, so we have more here. The numbers are pretty close to 200,000. Here they're going to be more spread out from 200,000, leaving more probability that we get something greater than the 200,000. Okay, and the very last problem here, we're looking at these four. Okay, so the true population is the arrow. Okay, and these are our sampling distributions. Okay, so first here, is this one biased or unbiased? Okay. The center of our sampling distribution would probably be about over here. Is that equal to our population parameter we're trying to find? No. So that's biased. Okay, is the center here equal to the true population parameter? Yep. Okay, pretty close. Yep, so that's unbiased. Here, the center of all this, is it equal to our population parameter? Yes. Here is the center of our distribution equal to our population? No. Okay, so unbiased would be 2 and 3. Okay, so unbiased would be numbers 2 and number 3. Now, which one does the best job of estimating? So we want the answer to be accurate, right? So we want it to be unbiased. So this one or this one's going to be the center and center, right? But which one's a better representation? This one is, okay? Because we have more data here. Here, we have numbers down here and up here that would be less accurate, but here it's more accurate, which means we had more in our sample here, right? This might be a sample of 100 versus a sample of 10 being more spread out, okay? So the best job of estimating would be unbiased and less spread. So example number 2 would be that. So we think about these here. Example 2, it's not very spread out and it hits the center, okay? We think about this one right here. This one hits the center, but it's spread out. It hits the center, but it's spread out. Whoop, can't see that. This one here hits the center, not spread. Hits the center, not spread. That's what we want. This one here hits the center, but very spread out. Hits the center, but spread out. Okay, this is ideally what we want. Okay, come to class with some questions for us.